for year 11 exercise 5H question 5. Okay, so we want to find expression for the area in terms of x and y. Okay, so if I break this shape into two rectangles, the area of the first rectangle will be length times width, which is 8y. The area of this would be, okay, we've got our height, we just need to know like our width. So the width would be, we know the total of here is y, so it means that this already takes x, so that's y minus x. The area would be x multiplied by y minus x. Okay, I want to find the expression for the total area. So the total area would be given by 8y plus x, y minus x equals 8y, and I expand that, xy minus x squared. Okay. Now, the second part, I want to find the primitive in terms of x and y. So the primitive will be given by all the sides added together. So y plus 8 plus x plus y minus x plus I take from x, that takes from 8, so plus 8 plus x. So let's combine, we've got two y's, we've got two x's, because these x's cancel out, and then you've got 8 plus 8, which is 16. Okay. Now, the second part of the question, because both the area and perimeter only contain x and y, we can't do much with it with two variables. Okay, so somewhere in the question, they try to make it so that you have one variable only. So the perimeter is 64. So for part, this is part 1, part 2, A, okay, part B, A equals 64, then 64 equals 2y plus 2x plus 16. We want A in terms of x only. Okay, so can you see A has a y in it? We want to find an expression for y which contains x only. Okay, so we need to make y subject here. So I'm going to move, so we've got 48 equals 2y plus 2x. I'm going to move the x to the side. Divide by 2, so that's 24 minus x equals y. Okay. So I'm going to now sub this in to the area formula. Okay, so for every y, we've got 24 minus x in place of it. Okay, so 24 minus x squared. So what I've done is simply replaced all y's with 24 minus x. Okay. Now I've got an equation in terms of x, which is great. That's what I want. Now the trick is you can expand this by hand or just use calculator to expand for you. Because remember, this is a SAC, so you can use the calculator. 24 minus x plus x, 24 minus x minus x squared. Okay, so what I'm going to do is I'm going to go interactive, transformation, expand. So I get negative 2x squared plus 16x plus 192. So area, I'll call it area of x equals negative 2x squared. What was it again? Plus 16x plus 192. 16x plus 192. Okay, so we've got the expression for area. So the key was it's in the same variable. Okay, so we already have x's, no y's. So we've done that. Now it says find the allowable values for x. So for allowable values for x, you've got to be sensible. Obviously, because looking at the shape, we've got x and y. X has to be greater than 0. Y has to be greater than 0 because we don't want areas to be negative, greater than 0. Now, the other tricky part is in our formula, remember how we've got y equals 24 minus x. So we know that 24 minus x is an equivalent expression for y. So 24 minus x has to be greater than equal to 0 because that's what represents y. So if I rearrange it, 24 is greater than equal to 0, not 0, x. So x is less than 24. X is also greater than 0. Now, there's also one more expression that we need to be wary of. We've got y minus x. So y minus x, that length has to be greater or equal to 0. Now, we know y is equal to 24 minus x. And so this equals that. If I minus another x, this results in 24 minus 2x is greater or equal to 0. So 24 is 2x, x is less than or equal to 12. So x is less than or equal to 12 sort of overrides this. X is less than or equal to 24 because this is smaller, and x is greater than 0. So x overall would be between 0 and 12. Now, I'm not going to expect everyone to know that because that's a very tricky domain to work out. Okay, so yep. So next part of the graph is sketch the graph A against X for these values and what is the maximum area. Okay, so to sketch the graph, you're sketching between 0 and 12. Okay, so I'm going to sketch the graph. This graph, I'm going to just drag and drop. Now you might have to adjust the domain because my line set's at 192. Okay, so you've got to be sensible with your domain. So your Y is definitely not at 4. You want to make it like 500 or something like that. Your X scale, we'll try 50. Let's say that. Okay, that's it. What we want. Now the graph's going to start 0 and cut off at 12. Okay, so we're not even counting the whole quadratic that goes down to the x-intercept. So let's work out what the intercepts are. Oh, we know the y-intercept's 192. The max is at 4224. When I draw the graph, got area, and we've got x. Oops, got x. So you're going to have a graph that looks like this. It's going to cut off at 12. So let's work out all the 4224. And let's work out where it cuts off at 12. So Nelson's GSolve, ycal. Okay, so when x value is 12, what's this y equal to? 96. Okay, so 12. So the graph rating goes here, 12, 96. So it doesn't extend the whole way. All right. So the maximum area would be 224. So A max would be 224 centimeters squared. Okay, centimeters squared. So I suppose this was quite a tricky question. You've got to do a bit of algebra. You've got to rearrange to make it one variable, and then the domain part was really hard. Okay, so if you didn't get that, that's okay. I do expect you to get at least a simple domain, but it's a good question to try. So hopefully that gives you an idea how to approach it.